Let's use example 911 on page 332 to demonstrate how to solve simultaneous equations with complex numbers using a TI calculator. First, we need to apply the node voltage method to determine the equations. We will write a KCL equation at node 1 and at node 2. Since we have a dependent source, we also need to write a constraining equation that describes the dependent variable Ix in terms of the unknown node voltages, V1 or V2. The circuit analysis yields three equations with complex coefficients in terms of three unknown variables, V1, V2, and Ix. To organize your work, rewrite the equations in a matrix format where you will represent each equation as one row. Put all of the constants on the right-hand side of the equation. Now you can formulate your problem as a simple matrix equation. Matrix A times the unknown vector, we'll call it x, is equal to the constants vector, we'll call this b. You can use your TI calculator to solve matrix equations with complex coefficients. First, turn on the calculator and access the matrix functionality. Create a new matrix. We make sure that you select matrix, not default, the default, which is data. We'll first enter the 3x3 matrix. Give it a variable name like A. Once you hit enter, you'll be prompted to input the matrix values one at a time. Enter these complex numbers the same way you would enter them in the home area. Once you have entered all the data, you are done with this screen. The matrix A is automatically saved as a variable in your calculator's memory. Now create another matrix, call it B. This will be a 3-row by 1-column vector where we will enter the constants of your system of equations. Now that you are finished entering in the data, you should go to your home area and compute the vector x as the inverse of matrix A times the vector B. The result is also a vector of 3 rows in 1 column in order that you've entered your equation. So we can conclude that the value of V1 is 68.4 minus J 16.8, etc.